Welcome back. Congratulations on finishing your first unit of the year on quadratic functions. And now we're moving on to our next unit, which is one of my favorite units ever, and that's on unit circle trigonometry. We're going to start with talking about radians and degrees, two different ways of measuring an angle. And then we're going to move into arc length and area of a sector, just different units of a circle. And then we're going to move into graphs of sine and cosine, and maybe a little bit of tangent, but mostly sine and cosine. So that will take us through unit circle trigonometry. Super important unit, and all of these things from the unit circle will keep showing up over and over and over for the next couple years. So let's start with radians and degrees. Maybe last year at some point you learned that 360 degrees is equivalent to 2 pi radians. And maybe you just kind of memorized, oh, it's 2 pi. And you memorized a bunch of things around a unit circle. Well, hopefully today I'm going to give you a visual of what that means. So let's start by drawing what a unit circle actually is. So we'll draw a grid here. And it goes 1, 2, 1, 2, -1, -2, -1, -2. What a unit circle is, it's literally just a circle with a radius of 1. So this is the unit, well, oval in that case, but it's a unit circle. So it's just a circle that has a radius of 1. So this is what all of this trigonometry stuff is defined by, is this unit circle. So when I'm talking about radians, radians is actually measuring this distance that's going around the circle. And you probably remember that the formula for, or the name for the thing that goes all the way around the circle is the circumference. And the circumference is 2 pi r, which when you have a radius of 1, makes it kind of simple. The circumference equals 2 times pi times 1 is just 2 pi. So if you were to go all the way around the circle, from start and to finish, your total distance traveled would be 2 pi. And that all the way around the circle is the same thing as 360 degrees. So hopefully you see that one lap around the circle is just a length of 2 pi. Which means that if you go 180 degrees, so now I'm just going to go halfway around that circle. So if I start here and I go to there, I went halfway around the circle, 180 degrees. I just went half of that 2 pi, which is 1 pi radians. So when you're talking about radians, what a radian is actually measuring, I'll get back to that conversion in a second, but what a radian is actually measuring is the distance traveled, I don't know if traveled has 1 or 2 L's now. You can look it up. Around the unit circle. So that's as simply as I can put for what a radian is actually measuring. It's the distance traveled around the unit circle. And if you want to convert degrees into radians, we have a simple conversion. To convert degrees to radians, we know that 180 degrees is equivalent to pi radians. So we can just multiply it by, from degrees to radians, 1 or pi over 180 degrees. And you'll see that the units will end up canceling out when we do that. So let's go ahead and convert a couple of these. 75 degrees, I want to know how many radians that is equal to. So what I'm going to do is I'm going to take 75 degrees and I'm going to multiply it by pi over 180 degrees. And by doing that, the degrees symbol here and here, they just cancel out with each other and you're left with radians. Now radians don't have units. So if you write a number without units, it's implied that it's in radians. So we end up with 75 pi over 180. And now we can reduce that. So if I want to reduce this, we could divide the top and the bottom by, one obvious answer you might come up with is 5. Let's start by reducing it by 5. So if I take a 5 and divide it on the top and bottom, we would have 15 pi over 180 divided by 5, it's 36. Then you look at 15 pi over 36 and you realize, well, both of those could be divided by a 3. So if I divide the top and bottom by 3, we get 5 pi over 12. And that's as reduced as it can get. So 5 pi over 12 is equivalent to 75 degrees. If you want to see like where it would be on a unit circle. 90 degrees is all the way up here. 75 degrees would be about there. So that angle measurement, we kind of understand it as 75 degrees, but in radian measure, what we just found was this length right here on a unit circle would be 5 pi over 12. So that's what a radian is measuring. It's just a different way of measuring an angle. We are kind of used to measuring things in degrees Fahrenheit, but we also measure them in Celsius. That's the same thing with an angle. We're used to measuring it with the degrees down here, but we can also measure it by looking at the length of the arc that is created. So a little different when you see those pi's in there, but that's all it's measuring. Let's go to 660 degrees. We want to convert this into radians. So we're going to multiply by pi over 180 degrees. The degrees will end up canceling out, and we will end up with 660 pi over 180. One of the easiest things we can do to reduce this is we can just divide the top and bottom by 10, and by doing that, the zeros cancel out. So we're left with 66 pi over 18. You might notice now that there's still even numbers, so you could at least divide them by 2. If I divide the top one by 2, we get 33 pi. And if we divide the bottom by 2, we get 9. And let's go one more. We can divide each of these by 3, and we get 11 pi over 3. So 660 degrees, which is like a full loop and almost 2 loops around a circle, would be 11 pi over 3. And let's go to 540. Again, to convert from degrees to radians, you can multiply by pi over 180. The degrees will cancel out. And hopefully you realize you could divide, well, let's simplify it first. 540 pi over 180. Again, you can realize that the 0 and the 0 cancel out. You're dividing the top and bottom by 10. If we have 54 and 18, both of them are divisible by, some of you might have gotten it. You could divide both of them by 18. So 54 divided by 18 is just 3. So this equals 3 pi. So 3 pi radians for 540 degrees. So go ahead and try the next 3 on your own. So pause that video, and when you're done, come on back. And there's your answers. Hopefully you got them right. Hopefully you reduced them all the way. Now we're going to just kind of draw these out and see what they mean. So if we have 5 pi over 6, what does 5 pi over 6 actually mean? Well, to get a visual, let's convert it to degrees. I'm going to go the other way now. So to convert radians into degrees, you can just flip that fraction the other way around so the pi's and radians cancel each other. So we have 180 degrees for every pi radians. And then you'll see that the pi's cancel out. So we can reduce this as we're multiplying. I would reduce the 180 and the 6. So if you cancel out 180 divided by 6, it becomes a 30. So I'm going to make this 30 and this one a 1. So now 5 times 30 gives us 150 degrees. So 5 pi over 6, 5/6 pi, is 150 degrees. That would be right about here. So here was pi radians. Remember, 180 degrees is halfway around the circle. We just went 5/6 of the way around to that pi. So if that whole thing was pi, we just went this length, which was 5/6 of a pi. And that was equivalent to 150 degrees. So I think it's easier to visualize for us when we see it in degrees, but we also want to be able to visualize it in radians, and that'll come with practice. We are now going to do 7 pi over 4. So let's convert that one into degrees. So we're going to multiply it by 180 over pi. So 180 degrees matches with pi. The pi's will cancel out. Now if we take 180 divided by 4, we can cancel that top and the bottom there as well. And 180 divided by 4 is 45. Cut 180 in half, you get 90. Cut it in half again, you get 45. And then we can take 7 times 45 and we get 315 degrees. So let's go ahead and draw 315 degrees. 315 would be right about there, halfway between in quadrant 4. So this would be 7 pi over 4 radians. It went all the way around here. It might be easier to visualize if you think of 7 pi over 4. I'll write it over here. 7 pi over 4 is just 1 3/4 pi if you convert it to a mixed fraction there. So going halfway around the circle, that was 1 pi. And now you'll see that we had 3/4 of a pi left to go. So there's half a pi, and that became the 3/4 of a pi. So 7 pi over 4 is just 1 3/4 of the way around this circle. So almost all the way around, not quite. Now we have a little different one. This one just says 2 radians. 2 radians, well, that doesn't have pi's in it, and that's okay. We can still convert it into degrees. So I'm going to multiply by 180 over pi. And to convert that into degrees, you can just type this into a calculator. So we get 360 divided by pi. And you can just type it in, 360 divided by, I'll do 3.14. That's 100, and we'll round it up to 15. I'll put squiggly lines, that means almost equal to 115 degrees. So we have 115 degrees. Let's kind of estimate where that would be. This is 90 degrees up at the top. So I'm going to go a little bit more. We're going to go about 25 degrees more than that. So right about there. This distance would be 2 radians. Now, if you think about this, that kind of makes sense, because if you were to go all the way over to here, this is pi radians. Pi is just 3.14. So instead of pi, think of this as 3.14. So if you were to cut 3.14 in half, 3.14 divided by 2, going up to here is 1.57 approximately radians. So that would make sense that this over here would be about 2 radians. Radians don't have to have a pi in it. They can be just normal numbers like that. So try the next 3 on your own. Pause the video, and when you're done, come on back. Pause. And there are your final drawings for each of those radians. One thing I want to point out for that first one, 5 pi over 3, if you convert it to a mixed number, it's 1 2/3 pi's. So if you went around to here, that's 1 pi, and then we had to go 2/3 of the way around that next 180 degrees to get there, and it was right about at 300 degrees. So hopefully you were able to get those. In the next video, we will do the ones that match up with the unit circle. Fun stuff.